I was wondering if we could get back to the 1940 time period. This is a new question. Can you tell us how after these 3 months you talked about before that you
Hey,
became an important link in getting
I
uranium
got
metal into the Manhattan Project? Could you
so
go
at the
into that?
steel mill, I got
This is now
how
at
the steel mills were
this is now at which company?
not only melting but fabricating. They had sheet mills, bar mills, and
Mm-hmm.
all of this. And I'm sure Dr. Chipman was talking to the director of the lab,
Mm-hmm.
uh, and this Dr. Bowden from Carnegie, Illinois Steel, and they decided I had enough and come to the University of Chicago. So I reported on the Monday, and he had to come down to the main entrance to get me through security because you had to be cleared for security to get into that building. And he took me up to the fourth floor and into this. It was a big office. There was a square from that wall to this wall, and then walked in there, and there's three individuals. He introduced me to them. Zaya Jeffries, Dr. Jeffries was a vice president of General Electric Corporate Research. And Dr. Greninger was a graduate of Harvard, did some classic work for his PhD, and he was an up-and-coming scientist with General Electric. And Dr. Foote was from Columbia, and he also did some classic work on stainless steel. And when he got introducing me, I probably quivered, wondering, I'm coming in with this group with a bachelor's degree, and because Dr. Chipman said, Andrew, there's my desk in this corner, Dr. Greninger's desk is in that corner, and Dr. Foote's desk is in his. That fourth corner is yours. If you don't think I was scared, wondering what I was getting into. And then they took me into this cubbyhole, had a draft board. They were looking at a laboratory design that was going to be the future laboratory that they took over away from the campus. And that was my introduction. And walking up from the past the security, Dr. Chipman let me know when I walked in that door, I was part of the team, and he told me, don't be afraid to talk, no matter what the question or comment you have. I was free to be part of it.
What was your assignment? What assignment did they give you?
After the assignment, gave me to get a laboratory, what turned out to be a washroom for a washroom, because it was a football stadium, Stag Field. They cleaned out everything out of there by the wash basin, and that was my laboratory. And built a vacuum furnace melting system. Never had copper soldering. But the University of Chicago had one of those characters. He was handy on all kind of improvements. And he would come around to teach me how to solder the pipes and valves and all this. And I put it together and it worked. And then I got a small cube of uranium metal. And what I would do is melt this under a vacuum, and then looked at the metallurgy under a microscope, and then take that sample and remelt it with adding different alloys, and go back and look at the metallurgy and see if we would see something happening to the grain structure. And did this quite a number of times. And while this is going on, we were involved in a lot of other things. You wouldn't believe it. You'd think I was telling you a story. And, there was no data on uranium, none. And any handbooks. So we were starting out from ground zero, and we had to develop the fabrication. And Iowa State University had the problem to separate the uranium from the uranium ore. And that's another interesting successful project. They did the melting, used aluminum particles, small particles, mixed it with the ore, and they had a quarter-inch thick pipe that they welded the bottom cap, put all this mixture into this, and welded a cap with a little hole to ignite the aluminum. Aluminum in small particles will ignite. You have to be very careful. And they used it for welding rails on the railroad, steel rails, exothermic reaction. That's going in the early stages of welding. And so they would trigger this, and the aluminum would take the oxygen impurities away from the uranium, and you ended up with molten uranium in the bottom and the impurities floating to the top. And then they were separated, and they used those clumps of uranium to the vacuum melt and pour about 3-inch diameter ingots, about 2 feet long,